Hello everybody. Here is a complex circuit diagram and I'm going to take you through how to solve a bunch of stuff about it. When you encounter problems like this, they will often take this format where you're given an incompletely labeled circuit diagram and you're asked to calculate various things about it. So there's a few questions in here and I'm going to take us through them one at a time. First one is to calculate the total resistance of the circuit. So that means we need to know the total we need to know the resistance of all the parts of it and how they add up. So we know the rules that govern this. We know the rule for resistance in series, and we also know the rule for resistance in parallel. When doing this sort of calculation, I usually like to start with what I think of as the innermost section. That's usually the smallest, most complicated section. In that case, that's this right here, R5 and R6. So in order to calculate the total resistance of that section, those are in parallel, so we use our rules for resistances in parallel and just fill in the numbers that we've got. We end up with 8/15, which as a decimal, and taking the inverse of is 1.875. As you can see, I've added my 1/3, my 1/5, 1/3, and 1/5, and then I've taken 1 over that. So that gives me 15/8, which is 1.875 ohms. Okay, so that is the total resistance of that one section right there. Then we want to move on to this whole section, R4, R5, and R6. We've calculated R5 and R6 put together, so we already know what that section is, and that section is in series with R4, and the rule for resistances in series is we just add them up. So we've got R1 and R2, sorry, that should be R4 and R5 plus 6, and that ends up being 6 ohms from here, plus 1.875 from our previous calculation, giving us 7.875 for this section here. Then we've got over here this other section here, R2 and R3. These are also in series. Our rule for resistances in series is, again, just add them up. So 15 plus 2 equals 17. So now we know this is 17 and this is 7.875. Next, we want to know the resistance of this whole chunk here, R2, R3, R4, R5, and R6. We now know the resistance of this chunk, and we know the resistance of that chunk. Those are in parallel with each other, so we use our rule for resistances in parallel, and that gives us 1 over 17. 17 is this chunk here, plus 1 over 7.875, that's this chunk here, and that gives us 0.185807656. Yes, you do need the whole thing, but that's not our resistance of that section because we have to take the inverse of it, which gives us 5.381909559. Again, yes, you do need all of it. So that is the total resistance of this whole complicated chunk here, is 5 and a bit. Then we want to calculate the total resistance of the whole thing. So we've got this chunk right here, and this chunk is in series with R1 right here. Our rule for resistances in series is add them up, so we do that. Total resistance of the whole circuit is 10 plus 5 and a bit gives us 15.381909559 ohms, but we have to round that to a certain number of significant figures. The way you work out how many significant figures you round a number to is what is the smallest number of significant figures in our given values. In that case, in this case, that's 1. We've got a 3, a 5, 6. Those are all one significant figure. 15.381909559 rounded to one significant figure is 20. Not 15, not 10. The 5 takes the 1 up to a 2, giving us 20 ohms. You round whenever you're answering a question. You take it to a certain number of significant figures whenever you're providing the final answer of a question. Any number that you're doing calculations with, you need all of the decimal points. I always want you to show me, anytime you have a final answer, the unrounded and then the rounded version of that answer. That way if you round incorrectly, I can still give you partial credit for the question. So total resistance of the circuit is 15.381909559 ohms, or 20 ohms depending on whether we round it or not.